Hey there, welcome back to the channel. I need coils. Not one, not two, many of them. For the first linear motor prototype I wound 3 by hand, which I remember as a truly traumatic experience. That really was a pain in the. So I did what any sane engineer would do. I built a machine. As always, every project starts with a concept. A base plate, holders, a spindle, traverse, motors, ball screw, electronics and controls. And eventually, all those individual parts slowly turned into an actual machine. Let's make some chips. For this project, I needed quite a few custom parts. And while I could machine everything myself, sometimes it's just faster to let someone else do the heavy lifting. These parts of the project are sponsored by JLCCNC. JLCCNC basically handles custom CNC parts from quick prototypes to full production runs, which is especially nice when parts actually need to fit together. For this build, I sent them a couple CAD files and technical drawings and got fully machined parts back just a couple days later, whether you need 1 part or 1,000. Pricing stays surprisingly reasonable, without setup fees. They use 3, 4 and 5 axis CNC machines to make sure every detail matches your design. And honestly, sometimes it's just nice to skip machining the huge plates yourself. Especially when you're trying to finish a project before the heat death of the universe. JLCCNC can deliver parts in as fast as 3 business days, which is kind of ridiculous. Definitely should have sent them more parts. They also offer $70 in coupons for new users, link in the description. But of course, where's the fun in not making chips? Which is slightly less fun when the garage is at -10°C. I decided to machine most of the parts myself, except the base plate and the motor mounts, to push my skills a bit further. Most of these parts are machined on the rotary table, and for this build I decided to make a sacrificial fixture plate. Each part has at least 2 key features, like external radii with a 5mm rimmed hole in the center or a large bore. These rimmed holes make positioning and flipping parts quick and repeatable. And once a part is done, I just resurface the fixture and move on to the next one. Wait for this shot, this is oddly satisfying. Alright, first part done, 4 more to go. But first, resurfacing. since it's been a while, I decided to design a proper PCB for this project. Via Simple UI, you simply set the parameters for the winding job and hit start. The microcontroller then pre-calculates the speed ramps, couple the traverse to the spindle, and send the right pulses to the TMC2209 stepper drivers and motors. Of course, I did some mistakes when designing the circuit board, forget the USB D+ and one wire pull-up, didn't debounce the encoder and the button, no test points, and the used controller doesn't feature USB DFU as a blank. Besides that, everything works perfectly. Now all of the parts are finished, we can start with the assembly. Now, we need a program, but before that, we need to know how to wind a spool. Sounds simple enough, but there's a bit we should consider. Most people know helical coils, and if you ever wound one yourself, you know at some point it just goes completely off the rails, no matter how hard you try. According to Wikipedia, this drops the fill factor to about 73%. What we wanna do instead is a orthocyclic winding. Orthocyclic winding. In a section view, it looks like a honeycomb. To understand what is going on here, let's unwrap the winding. Every turn is parallel to the others, no matter which layer or which direction we're winding in. Each turn crosses over only at one control transition point. And also in this area, the layers cross, in theory. As a result, every turn sits in the belly of the previous layer. That increases the fill factor to the theoretical maximum for round wire. That's about 17% more coil per coil, compared to a normal one. That's what we're attempting. And there we go. 3, 2, 1. And somehow, after all the redesign, broken tools, firmware bugs and frozen fingers, it actually works. Kind of. At some point, the wire jumps over a valley and messes up the winding. I guess there's a small bug in the program which causes that. And maybe the wire should be tensioned more. Do you have any ideas for improvements? If so, please let me know in the comments. Alright, that's it for this video. Thanks for watching till the end. This took way longer than it probably should have. So if you liked it, feel free to like and subscribe. See you next time.